Just getting that document open, and then, wow, it's a lot of stuff here. Okay. Let's keep going. I guess we'll put these at the end. All right. Okay, so question 9. All right, let's have you look at this, and then we'll go back to the moving man. So let me share my screen. Do share. Why is this so difficult to find? Okay, there it is. All right, that should be up on screen. It says, first, we are going to compare constant velocity to constant acceleration. Do a simulation where the man moves with velocity of 2 meters per second. Then next run a simulation where the man moves with constant velocity, constant acceleration of 2 meters per second squared. Describe any differences in positions versus time. And then we're gonna do the same thing for that. All right. So I'm gonna show you how to do this, and then we'll go back to writing up some answers on it. So let me get that pulled up. It'll take just a moment. The moving man. All right. So we're actually start with the moving man at -10. And we're gonna give him a velocity of 2. And he's gonna go all the way across the screen. He's gonna hit the wall over there. Is that you ready for that?
Yeah,
Okay. There he goes. Go, go, go. He's moving along.
very slowly, but he's making it.
He's gonna make it. Okay. So he's at the wall. What do you notice about the velocity here?
It's a straight line.
It's the same. In its position, he's covering the same amount of ground each time. All right. So now we're going to go back to -10. This time we're going to give an acceleration of 2. Okay. And we're going to see what happens. So let me know when you're ready.
Yeah, I'm ready. You want me
Ready.
to do you
Just
want me to
watch.
write it down somewhere? Oh wow.
Nope, nope, nope. I just want you to watch and create a visual of what's going on here. All right. So what happened? What did you
It
see?
and so from the velocity, it went from a straight line, then it just started curving a
So the
little.
red's the velocity. So the velocity here shows that he had no velocity, and then his velocity increased until he hit the wall.
Yeah.
So his you ever been at a traffic light and then you hit the gas pedal really hard?
Yes.
That's what's going on here. You speed up.
Oh.
Now, for the position here, it took him about 10 seconds to cover. It only took about
Yeah.
5 seconds, 4 seconds. So it was much, much faster. Okay, I know it doesn't ask for it, but we're going to put a snip in of this because, hey, why not? Why not? Okay, let me go grab a snip and put this into the other window. All right, I'm going to grab another snip of position versus time for us to look at. Okay, we go back to the other screen. Um, okay, we'll try this. You can tell me if you need us to do it again. All right, it says describe any differences in the position versus time plot for these two curves. Okay, so we're looking at, this was the constant velocity. And in the constant velocity, we said that he's covering the same amount of distance per unit time. That's what this line indicates. It's like when you're on the interstate and you're just going at the same speed. In the second, oh, I can't find that. All right. In the second box, he ends up covering more ground, constant acceleration. Covers more time, more distance per unit time. The curve kind of it's flat versus, and then it becomes much steeper. So we might talk next about the slope of the line
Okay.
is always the same. And in this next part, the slope of the line is getting steeper. Is that okay?
Yeah.
All right. So you've got to put that into your own word.
Okay.
Things that are the same, things that are different.
Okay, I just finished writing
All right,
and
let's
I
take a look what you got.
okay.
I like that. Okay, so now we're gonna do the same thing for velocity. I'm gonna grab a snip of it. We want to avoid saying things like straight line because all lines are straight. We want to say that in the constant velocity, which is the first one, it's a horizontal line. And we shouldn't be surprised by that because the velocity is always the same. In the constant acceleration, the velocity is increasing. The reason for the increase is the acceleration. So could you reformulate that into your own word, please?
Yeah, sure. Okay, I just finished typing.
Okay. All right. Any questions on that?
Nope.
I'm getting tired of the moving man, but we
We have to finish it.
we have to do it. That's part of being an adult, is you do a lot of things you don't want to do. All right. So it says here, first we're going to compare positive negative velocity. Do a simulation where the man moves the velocity of 2 meters per second. Next, run a simulation where the man moves with the velocity of minus 2 meters per second. How does the difference change in the direction the man walks? Okay, so we're going to get to that. Okay, so I'm going to reset all. We're going to put the man back at the middle. And we're going to go 2 meters per second for 5 seconds. Let me know when you're ready. Are you ready?
Yeah.
All right, you don't have to do anything. You just have to watch the man move. The moving man.
Yup, the moving man.
The moving man. He is moving along. All right.
Okay, 5 seconds.
Okay, so is the velocity above or below the x-axis?
Above.
Above. Okay, so keep that in mind. Now we're going to put the man back in the middle. And we're going to change him to minus 2 meters per second. Notice he switches to the other side. And we'll let him go for 5 seconds.
That time
Okay,
it's technically 10 seconds and it went below the x-axis.
exactly. So I'm gonna grab a snip of this and we're going to look at it in the other screen. All right. Let's go to the other screen. Okay, what is the man's speed in each of these simulations? Speed is the absolute value of velocity. Okay, so speed doesn't care what direction you're going, whether you're going north, south, east, or west. When you look at the speed in your car, it's telling you how fast you are going, not the direction you're going. Okay, so what
Okay.
is the velocity in the first scenario?
Um, it's above the x-axis. Oh wait, yeah, it's above the x-axis.
It's 2 meters per second. So what is the speed? Well, the speed is the absolute value of 2, which is 2 meters per second. Okay, now we're going to go for simulation 2. What was the velocity in simulation 2?
-2 seconds.
Negative
Meters per
2 meters per
second.
second. Okay, and what's the absolute value of negative 2? Absolute
N
value always returns positive.
Yeah, it's gonna be 2, sorry.
Okay, so can you give me one sentence that says that in each simulation the speed is the same?
Yeah. Sorry, I'm like also eating my breakfast lunch
Take
kind of
take your
things.
take your time. We will definitely get through all this. So it
Yeah.
may not even be worth going on to something new anyway. So um, just take your time. We got plenty of time to get this done.
Okay, I just wrote something.
Okay, so not quite exactly what I was asking for. We want to say the simulation, um, the speed in both simulations is exactly the same.
Okay.
All right. Okay. Now we saw this. How does this difference change the direction the man walks? Um, he started out by going this direction, then he went this direction. Could you could you describe that in your own words? You want to use words like positive velocity, right? He's moving right. Negative velocity, left.
Got it.
So could you put that together into a couple of sentences for us, please?
Okay, I just finished writing it.
Take a look here. Yep, that is correct. There's nothing more, nothing less needed. Okay. All right. So explain any differences in the position versus time plot. Um, so we're looking at, let me grab a snip of just the position versus time. So we're looking at this first part, and then we're looking at this next part. Basically, you want to describe those two lines as best you can.
I have to describe that line.
Like each of those boxes, describe what the line is doing.
Should I say like for the first one it's becoming a it's not horizontal, it's becoming like a diagonal line. I don't know.
You want to talk about the slope. Slope. So if a line goes up and to the right, see how the blue line's going up and to the right?
Yeah.
That's a positive slope.
Okay, got
And then
it.
down and to the right is a negative slope. And this is consistent with it moving to the right, to the left.
All right, I just wrote it.
Okay. So we want to use the word slope in there. Can you rewrite that so that it uses the word slope?
Yeah. Oh no, wait, what I click quote by accident? All right, there we go.
All right. Okay. So, all right. The start the line is going upward, making slope positive. When it goes down, slope to negative. Okay. You still haven't talked about the direction they're going.
I thought I
Like
did.
to the right, to the right, to the left. You're talking about the man or the woman if you
Oh,
want. But we need to add that in.
everything is so complicated. Oh my goodness.
Almost done. So just if you could just revise that a little bit more, add that in the first line, he's going to the right. Second line, he's going to the left.
All right, there we go.
All right. Okay. Yeah, I like what you've done here. That will be everything. All right. So let's get that in there. Okay. And then we can do the same thing now for velocity. Let me grab a snip of that. Um, this should be a little easier because it's it's when he's moving to the right, it's above the x-axis, positive velocity. Moving to the left, it's below the x-axis, negative velocity. You want to also indicate that it's constant in both cases. Okay, constant just means that it's horizontal. Is that
Okay.
clear?
Yes.
So give me few sentences here for this.
Okay. Okay. I've just wrote something in the chat.
Let's see if we can. All right, that's it. That's perfect. Nothing more needs to be said. Okay, so I'm going to send you these notes. So you'll be able to submit this. Well, I guess you can't submit this yet. You'll be able to submit your English day, your revision to the PH lab, and then you said you maybe between now and next time we meet, you'll be able to get the other lab done. And so we're moving and doing great progress. I would recommend on Thursday we work on English,
Okay.
but I'll leave that up to you. So we're going to stop here for today, and I'm going to